Continuing the previous example, so after we finished the factoring, we got 3 factors. You can think of them as 3 boxes. So we're going to take the stuff out of each box and set it to equal to 0. So 2x equals 0, x plus 1 equals 0, and x minus 1 equals 0. And now we just have to do an extra step to get all the x's in each equation by itself. And because these 3 equations are different, we have to do different operations. So in the first case, it's multiplication. I'm going to reverse multiplication, so I do division. And 2 cancels 2. I got x. And 0 divided by 2, we get 0, because imagine that you have $0 split among 2 people, everybody gets $0. In the second case, since we have to get rid of plus 1, we're going to reverse addition. We do subtraction. And so we end up with x equals -1. And the last equation, we have -1. We reverse -1. We do +1. So we get x equals 1. So we have 3 answers. And a good tip is if you highest the exponent of x is 3, so usually you will get 3 solutions. And sometimes two of them could be the same thing, but in general you should have 3 solutions. And if you have time, plug each of the numbers into the equation and make sure after you work out these operations, you do get 0. Okay, so I'm going to skip the checking part there. But and so now let's look at the last example here. So 3n third equals 27n. So first we got to make sure one side is 0. And notice neither side is 0. So that means I have to move one side to the other side. So I'm going to get rid of 27n by subtracting it. So I'm going to subtract both sides, 27m, subtracted 27m from both sides. Now on the right hand side, they cancel out and we got 0. So if you have something, you got rid of it and you have nothing left, which is 0. The left hand side, we just have to keep it as 3n third minus 27m because they are not like terms. We cannot subtract them. So let's start with the GCF. And notice they have 3 and n in common. That's the GCF type. If you are not familiar with the GCF type, make sure you go back to watch the GCF factoring. So 3 and 27, we factor out to 3 and we factor out to n. So we're going to divide both of them by 3n. And 3 cancels 3, and third divided by n is n squared, minus, bring down minus, 27 divided by 3 is 9, and n cancels n. So now we have 3n times n squared minus 1. Since we still have the second power, n squared means 2 copies. So we may still be able to factor n squared minus 9. Again, as you can see, 9 is a perfect square. So now this is the difference of 2 squares type. So we put a 1 copy here, one copy in the first box, 1 copy in the second box, 1 copy in the first box, 1 copy in the second, and a plus or minus, minus or plus. The order doesn't matter. Okay, so I'm going to bring down 3 and n. But for n squared minus 9, I was able to break further, n minus 3 and n plus 3. On the right-hand side, I keep it. Equal sign, keep it 0. So again, this is like we are having 3 boxes. So we can set the stuff in each box equal to 0. So I have 3n equals 0. Or n minus 3, this is the first one, this is the one in the middle, or the last one. And again, we have to solve each equation individually because they are all different operations. So similarly, 0 divided by 3 is 0 because $0 split among 3 people, each person gets $0. So add 3, minus I do plus, plus I do minus. So we have also 3 answers, 0, 3, and -3. And again, I'm going to do a quick check here. So if I want to check my answer, this is what you do. Let's say I check the first answer, 0. I'm going to take the original equation, which is this, and I'm going to replace the letter n, this letter n, with the first answer, 0. So that's going to give me 3 times 0 cubed equals 27 times 0. That's apparently correct because 0 cubed is 0 times 3 is 0. The right-hand side, 27 times 0 is 0. So that means 0 is correct. If you want to check whether 3 is correct, you can do the same thing. But this time, you're going to have to replace n with 3. Going to replace n with 3 here and 3 here. And 3 cubed is 27, and times another 3. And the right-hand side actually is also 27 times 3. You can see, you probably don't even need to work out. You can see 3 times 27 equals 27 times 3. And similarly, if you want to check whether negative 3 is correct, you can replace n with negative 3, and then you will get 3 times negative 27 and 27 times negative 3. And notice a positive times negative will give us negative. So it's you can work this out. 27 times 3, that gives us 81. So you will get negative 81 on the left and negative 81 on the right. So that still tells us negative 3 is the correct answer. So if you want to have time and you want to make sure you got the correct answers, you can do that.